Section 6.3 is more on trig equations. It's actually listed as Trig Equations Part 2. So there's a little bit more to it, but we don't have as many problems. We're still working same process. So on this example, it says solve cosine 2x equals cosine x over 0 to 2 pi. So we need to use an identity for cosine 2x. And the identity that works is this one here, 2 cosine squared x minus 1, because we have a cosine over here, and that way we'll all be in cosine. So we substitute that in for cosine 2x, then subtract this cosine over here so we have something that looks quadratic, 2 cosine squared x minus cosine x minus 1. So if you think about it, it's a little easier sometimes. Let a be cosine x. So 2a squared minus a minus 1 equals 0. So then you can factor that and you have 2a plus 1 and a minus 1. Take both of those and set them equal to 0 and solve, and you get 2a plus 1 is 0, subtract the 1, divide by 2, and you have a is negative 1/2. And over here you just add the 1 and you get a is 1. Now put your cosine x back in, and so you have cosine x is negative 1/2 or cosine x is 1. Where does that occur? Well, for negative 1/2 it is 120 and 240, and for 1 it is equal to 0. Then if we need it to be in radians for this part, it's 2 pi over 3 and 4 pi over 3. So the only thing really different than what we did in 6.2 was we needed to find an identity to use to substitute for that. So you may encounter that in your problem set. Let's go look at our homework problems. All right, so this one says the cosine x is negative 1 is pi. So they said the solution set for this equation is pi. Use this information to solve the following. So now this is what we're going to actually solve. All right, so it's got a cosine 2x. This is what we're going to use to substitute. So I substitute that in for that equaling negative 1. Add 1 over here, I've got 0. Divide by 2, I've got cosine squared is 0. There is 2 places where cosine is 0, and that would be pi over 2 and 3 pi over 2. And so that would be our answer. So you really, we didn't have to do much with that. We are going to use this, and I think that should make sense. All right, number 2, we're going to solve this. Cosine 2x equals 1/2. So we're going to use that same identity and substitute in for cosine 2x. Add 1, and 1 plus 1/2 is going to give us 3/2. Divide by 2 is the same as multiplying by 1/2, so you get 3/4. So cosine squared x equals 3/4. Take the square root of both sides. So you have cosine x equals plus or minus square root of 3 over 4. We can take the square root of the 4 and get 2. So now we have plus or minus square root of 3 over 2. And we are in the interval 0 to 2 pi. So where do we have a cosine that's square root of 3 over 2? That's 30 and all its reference angles. So 30, 150, 210, 330. And then I put them in radians. So you would have 4 answers to that equation. The solution set for this one, we're going to use this. We're going to do this very similar, but it is a little bit more involved. So we have cosine 2x equals square root of 3 over 2. And where is cosine square root of 3 over 2? It's at pi over 6 and 11 pi over 6. And they were telling us this right here. So we can think of that, but this was cosine of 2 pi over 6. If you divide this by 2, it's the same as multiplying by 1/2. And we can do pi over 12 and 11 pi over 12. Then we also know that 2x could be pi over 6 plus 2 pi. And so that's going to give us, if we have 2 pi over here, that's like 12 pi over 6. Remember, 2 over 1 equals how much over 6? Well, that's got to be a 12. So 12 pi over 6 and 1 pi over 6 gives us 13 pi over 6. Divide that by 2, and you have 13 pi over 12. We could also take the 11 pi over 6 and go one more revolution, since it's the 2x. And so we have 12 pi plus 11 pi is 23 pi over 6. Divide it by 2, you get 23 pi over 12. So those are your 4 answers, all in 12ths. And we did use this to get started, but that's how we did that one. All right, number 4, same kind of idea. Where is sine 2x equal to negative square root of 3 over 2? And it tells us that basic sine x for that is 4 pi over 3 and 5 pi over 3. So I did that here. I had the 4 pi over 3 and the 5 pi over 3. If you divide by 2, you end up with 4 pi over 6, which reduces to 2 pi over 3. And if you do this one, it's just 5 pi over 6. Doesn't reduce. And then we also have to go another revolution. So it's 4 pi over 3 plus 2 pi. And that's going to be 12. It's over 3. Sorry, that's going to be 6 pi over 3 plus 4 pi. That'll be 10 pi over 3. Divide by 2 is like multiplying by a half. You get 10 pi over 6. And that's 5 pi over 3. Do the same thing with the 5 pi over 3, and you end up with 11 pi over 3. Divide by 2, you have 11 pi over 6. So you have 1, 2, 3, 4 solutions to that. Suppose you're solving a trig equation for solutions over 0 to 2 pi, and you get 2x equals these 3. What are the corresponding values of x? Well, you're going to divide by 2. So if you have 2 pi over 6, that becomes pi over 3. If you divide that by 2, you've got pi. If you divide this one by 2, you have 8 pi over 6, which reduces to 4 pi over 3. So it's like you're multiplying each of these by a half and reducing. Number 6. You are solving for over 0 to 360, and you've got 3 theta equals 180, 630, 720, 930. What are the corresponding values of theta? Well, you need to divide by 3. That's all you do all the way across: 60, 210, 240, and 310. 7. Cosine 2x equals 1/2. Where does cosine equal 1/2? Well, that's pi over 3. But it's 2x, so you're going to divide by 2, so you get pi over 6. And it's also at 5 pi over 3, which if you divide, you get 5 pi over 6. Then you need to add the 2 pi to each of those, and you end up with 7 pi over 3. And divide by 2, you get 7 pi over 6. Here you get 11 pi over 3, divide by 2, you get 11 pi over 6. Where is sine 3 theta equal to 1? Well, if theta is between 0 and 360, if you have 3 theta, you've got, this still is 0, but 360 times 3 is 1080. So 3 theta, you got 90. And then you've got 450, and then you've got 810. What did we do there? I added 360 to the 90 degrees. That's where sine is equal to 1. And so I got 3 values. But because it's 3 theta, then I need to divide by the 3. 30, 150, 270. but I had to know how far I could go to get my 3 theta. So that's how you do that. You have 8 questions, but I think you've got what you need to be able to solve those.